Assalamualaikum. My name is Atika Yusri. Today, I would like to present uh, the intragranular stress corrosion, cracking of steel gas pipeline in weak alkaline soil electrolyte. Uh, the stress corrosion cracking of pipeline steel is one of the most important problem of operation of high pressure during gas pipeline. So we have two objectives. First is study fragment of pipe containing crack, and the second is soil sample of the excavation site of the gas pipeline. So we move to failure material. The first failure material is failure in pipeline steel, and the second is failure in gas pipeline. For failure in pipeline gas, uh, failure in pipeline steel is locate local anodic dissolution of the metal has major effect on crack growth in pipeline steel in weakly of acidic and neutralized electrolyte. And then for the failure in gas pipeline, the gas pipeline are related to stress corrosion, cracking with sign of the intragranular character of propagation into the depth of metal according to the mechanism of local anodic dissolution of the metal at the grain boundary. Okay, that's all for me, and I will pass to my group member. Thank you.
Okay, thank you, Adani. Um, Assalamualaikum and hi. My name is Nur Atira binti Ramli. Metric number is AC19057. So now I will continue for the background of material failure, method to analysis, failure analysis, and the material use. So based on the journal, the failure that happened to the pipeline include the different natural climate region in the country. Other than that, the factor of different manufacturer that produce the pipe also give the effect. Thus, they will produce the different design and size of the pipeline. Next is the contact of the pipeline with the soil electrolyte due to tape coating, disbandment, and the pH of environment that will give the harmful to the pipe. Furthermore, the others background of the material failure are hydrogen present and anodic dissolution. For the method to analysis failure analysis is the sample was cut with an outer diameter of 1020 millimeter and a nominal thickness wall thickness of 10 millimeter. The steel composition with the spectral lab as emission spectrometer. Then use the method of microstructural characterization by using the SEM and EDX. After that, define the qualitative and quantitative composition of crack by using SEM and observe the microstructure with SEM. The material that used is at 60 pipeline stay. That's all from me. Next, I will continue for the next group member.
Hello, my name is Nishali Suresh, SC19022. Well, let's move on to the next part, which is result. In aspect of visual inspection, figure 1A depicts pipe pieces with partial coating disbandment in the areas of the highlights floors, while the SCC defects on the metal surface of the pipes in figure 1B were narrow. Short colonies, accumulations of cracks in the longitudinal orientation relative to the pipe axis. There were almost no corrosion flaws on the pipe surfaces around the crack sites. In the process of visual examination, corrosion pitting with a depth of up to 5 mm was discovered with other areas of the pipeline as illustrated in Figure 1C. Microstructural tests revealed that the studied steel exhibited a banded ferric pearlite structure on the right, while on the left there is the presence of manganese sulfides. Illusions in steel is indicated by a high quantity of Mn and S in the composition of these illusions as determined by EDX. The figure below describes the appearance of flaws after etching. This sort of fracture propagation implies that the SCC of pipeline steel is intergranular. Aside from that, it depicts a typical view of the fractures identified in the gas pipes section with a depth of 4 to 5 mm, which is 40 to 50% of the pipe's wall thickness. Following that, a pipe surface with a metal corrosion flaw is depicted in the context of corrosion defects. However, there is no cracks in the corrosion pitting's bottom. Finally, SEM examination revealed that the studied steel's microstructure conforms to a ferric pearlite structure with considerable bending. Corrosion develops along the borders of ferrite grains, and the arrows indicate the source of corrosion damage along the boundaries of ferrite grains. That's all from me.
Good day, Doctor. My name is Gan Yu-eun, student ID SC20014. From the microstructural observations that mentioned above, it can be concluded that the identified cracks in the area of the gas pipeline are related to stress corrosion cracking with the signs of intergranular character of propagation into the depth of the metal follows the mechanism of local anodic dissolution of the metal at the grain boundaries. In order to solve these problems, it is necessary to perform additional field measurements of soils for the investigated section of the gas pipeline to determine the pH, oxygen and sulfide and carbonate ions, as well as the corrosion potential of metal in the soil. Another method of preventing the local anodic dissolution of the metal is the use of inhibitor protection. In conclusion, the predominant mechanism for the formation and development of stress corrosion cracking is local anodic dissolution of the metal at the grain boundaries. This study indicates that the area of propagation of high pH stress corrosion cracking may be somewhat wider than previously thought. In particular, it can be associated with various anionic compositions of soil electrolyte and may proceed in different geological and climatic conditions. That's all from our group. Thank you.